Hi, I'm John Derry, a Senior Application Engineer with Promess Incorporated, and today we're going to discuss the initial setup and the basics of UltraPRO. Today I have a 3 kilonewton EMAP press. This has 3 kilonewtons of force capacity and 100 millimeters of stroke capacity. We're going to walk through the initial setup and creating a basic program. So the first thing to do once your EMAP is set up, it's wired, your electrical panel is taken care of, is ensure your safety circuit is working correctly. So today on my screen, you can see I have this little E with the red and yellow around it. So that indicates I'm in an E-stop or a safe condition. So I can test that by opening the E-stop and seeing that my system is now ready to take a command. And if I press the E-stop, I'm in an E-stop or a safe state. From here, the first thing we're going to do is create a very basic program. Today I have a die spring to press on, so we're going to use that as a simulation of a part. To create a program, I'm going to navigate to our menu in the upper left-hand side of the screen and click New Program. For today's demonstration, I'm going to call it John's Program. Once I have my program opened, you can see that it brings up the UltraPRO editor software. From here, I'm able to have commands that make the press move up and down, apply load, as well as acquire and analyze data. The first thing to do when you're setting up a new program is to determine your rapid move. This is the move that brings the press from its starting position to just above your part, usually to save cycle time. To do that, I'll use the jog function in UltraPRO, so I'll have to put the system out of E-stop and then click the jog button. From here, I'm going to slowly jog the press to just above this spring. Once I'm almost touching the spring but not quite, I'm going to record this value, which is 57.32 millimeters. From here I can go back to the editor and I can click under this right-hand column and add a move step. I can then tell the press that I want it to move 57.32 millimeters at a rate of 25 millimeters per second with a relatively low overload as we're expecting to move through free air. The next move I'm going to add is a move back to home. I'll do this at the same 25 millimeters per second, but I'll use a slightly higher overload at 1500 newtons. So I'll go ahead and save this over to the UltraPRO controller. I can then go to the UltraPRO HMI. You'll see that homing is required because we manually move the press. I will click the home button, and the press will return to its starting position. From here, I can then go to Load Program and load John's program. If I click Cycle Start now, you can see that the press moves down to 57.32 millimeters and then immediately back up to 0. The next logical step in this would be to apply some force to my part. So I'll go back to the editor and I will add a Move to Signal step, which is a step that allows us to move to a sensor value. So this could be a force transducer like we have integrated into the EMAP, or it could be something like a digital probe. So I would like this to achieve, let's say, 750 newtons today at a speed of 10 millimeters per second. I can then save this to the controller, navigate back to the HMI, and once again click Cycle Start. Here we should see the press achieve 750 newtons and then retract back up to the home or start position. The next logical thing to do would be to add some sort of constraint around this. We need to collect data and analyze that data. So once again, I'll go back to the editor. I will then click on my monitoring tab in the upper left-hand side and create a new monitor. I'm going to name this monitor Force versus Position. Once this monitor is created, I can see that I'm going to record actual position and actual force. Now I need to add some trigger points in my program that will tell this monitor when it should start and when it should stop analyzing data. So first I'll add a start monitor just above the move to signal, and then I will add a stop and analyze monitor just below my move to signal step. Once again, save to the controller, and once we go back to the HMI, we should see that there is a graph displayed. So now if I click Cycle Start, the press will once again press the 750 newtons, and we should see a signature curve of that pressing. Now we would like to probably apply some limits to this to say what is a good part versus what is a bad part. So I will open my monitoring tab again. I will click the toolbox. I can click Show Graph, and I can use that last cycle as a reference actually. This allows me to apply my strategy to the previously ran part without running new parts, kind of like a trial and error. This is a patented Promess software feature that we call data analysis by example. So I'm able to use the previously ran part as my example to apply new analysis features to. The first one I'll apply is a window. So this will be a bounds set by position in this case, and it will create a window in which I'm going to analyze data. For this example, I'm going to choose 69 millimeters to 72 millimeters. And inside this window, let's say I wanted to have relative limits. So these are limits that trace the last part you ran or the average of the last parts you ran and apply a relative force value to that. This allows you to teach in a nominal part and compare all future parts to that nominal. For this example, I can tighten these limits up quite a bit. So I'm going to say plus and minus 10 newtons will be my limit. All right, and then we'll navigate to the lower and do the same thing here. All right, so I can then go back to the acquire and say I'd like to capture the maximum position. I can click maximum X, and this will allow me to store final position. And then I can do the same thing for maximum Y and grab the peak force that we see in this curve. So once we have both of those added, I can then save to controller, navigate back to the HMI, and once I run another cycle, we should see those changes appear on the graph. All right, so up in our status bar, you can now see that we have this OK that populates. This indicates that that was a successful cycle and this part is good. So now you can see that I have my limits and peak force and final position shown on the curve. Next, I'd like to add them to the gauging table. The gauging table is essentially a spreadsheet that captures values and holds them to limits that are set by the user. So if I navigate to the steps, and I can add the gauging step on the left-hand side under main. So in the UltraPRO software, I'm able to grab values directly off of the curve. So I'm selecting the peak force Y value, and I know I'm commanding 750 newtons, so my peak force should be relatively close to that. For this example, I'm going to set 725 and 775, giving me a plus and minus 25 newton window. I'm going to call this peak force, and then I'll add another one just below that for final position. For final position, I'll use the final position X value. So based on the previously ran parts, we can see that our final position was just about 72.1 millimeters. Knowing that, I can put in 72 millimeters up to 72.3 millimeters, giving us a little bit of tolerance variation there. Also label it final position. Now if I save it to the controller, and run a cycle, we can now see that we have peak force and final position displayed in our gauging table, along with date and time, cycle counter, and the serial number if one is sent over. So now that we're collecting data and we're analyzing that data, I can change this blue die spring out for a green spring with a less of a spraying factor. Once this is loaded, I can then press cycle start. We should see a dramatic difference in the graph between these two springs. This part should fail. So we can see that this graph did not pass through the limits that were set. The peak force was still okay, however the final position also failed. This spring was compressed much further than the blue spring. For a less dramatic test, we can go back to the blue spring and do something as simple as add just one business card on top of the spring. This indicates or shows a positional variation in components. Now if I press cycle start, The press will then again try to achieve 750 newtons. However, we can see that just with this little business card, we're outside of our limits. So we failed for final position as well as the relative limits that we programmed. Thank you for joining us today for a brief overview of how to get your UltraPRO up and running with the EMAP servo press. If you have any more questions, please feel free to reach out to us at 810-229-9334. Thank you.